Great. So I'm excited to talk some more about Compatibility Matrix and some of the changes that we've made and how to actually find a good way to use Compatibility Matrix in a CI pipeline. But before we start, I want to talk just a quick reminder. It is a newer product that we have. So I want to kind of do a refresher on what is Compatibility Matrix if you haven't seen it. Compatibility Matrix, Grant had mentioned it earlier. It's a service that we have that provides quick access to customer representative and test environments. It's really targeted for you being able to test your application in very customer representative environments in CI before you ship it. And we include a lot of different features in it. We have an increasing number of Kubernetes distributions and the versions of these that try to match what customers might run. When a cluster is created, it has a TTL, a time to live on it, so that you don't have to worry about deleting that cluster after the CI is done in ongoing costs. It'll automatically expire if you don't delete it sooner. And it's billed at a per minute usage for the clusters. We support various types of clusters. We have VM-based clusters that are hosted on our own bare metal servers. We have our machine types. We support today a few different versions of Kubernetes from Kind, K3S, OpenShift, which is a good one we'll talk more about, curl, and the new replicated embedded cluster that Alex demoed earlier today. We support various versions of Kubernetes across these. These are like 124 up through 128. Some of the version skew is a little bit different just because the different underlying distributions have different support for different versions. And for OpenShift, we support versions 4.10 through 4.13 inclusive. And those are the OpenShift versions that match the underlying Kubernetes versions. For our cloud-based clusters, these are real cloud-based clusters. We support EKS, GKE, and AKS, so AWS, Google, and Azure. Again, the latest supported versions that they actually provide there. And we support common machine types, including different underlying architectures from AMD 64 to ARM 64. What's new since we last presented about Compatibility Matrix, we now have upgrades for curl clusters. We have a cluster history view, cluster verification. I'm going to talk a little bit more about that. We show who created the cluster and allow you to extend the TTL of the cluster, and tagging and multiple nodes for K3S and curl clusters. So tagging and showing you who created the cluster is a feature that's visible now inside the vendor portal and in the CLI. All of the features of Compatibility Matrix work in the CLI and in vendor portal. Tagging is just really, it's a common pattern seen in other cloud providers. It's the ability to pass key value pairs into any cluster that you create, and we store those. And you can see on the example here, there's like a department equals QA. Tagging is really, it doesn't affect the runtime of the cluster at all. It's just there and stored in the cluster history, so you can filter reports and in views and billing information based on that tag. It's there for you to put metadata in that you might want later. And then we also show who and where and how the cluster was created. So in the example on the screen, I created this cluster using the web UI, but if a GitHub action created it, it'll show the repo and link back to that. If the CLI created it, it shows that. So it's, again, a useful way to just filter who's creating the clusters and why. So if you see a cluster that's running for a long time or unexpected clusters, you can track down easily where they're coming from. The cluster history page is a new view that we have in the vendor portal. It's sortable, filterable, pretty customizable, and it shows you the history of all of the clusters that you've ever created. You can see how many clusters, the number of minutes. You can actually change the columns. You can view the tags here, sort and filter by tags. So in the previous example, I had department equals QA. I only want to see clusters that have been created with the tag with department set to QA. I can do that. I can see the nodes that are on them, everything. The other new feature that we've recently launched that I wanted to talk about is a cluster verification step. What we really focus on giving you reliable infrastructure with Compatibility Matrix. When you provision a VM-based cluster or a cloud-based cluster, we have to go through the process of creating that, spinning it up, getting a kube config. And what we were doing before was once that's done, we would give you the kube config and you could actually run your CI against that. One of the changes that we've made is now we actually run Sonobui, install Sonobui and run a set of Kubernetes conformance tests on the cluster before we give that to your CI pipeline. The main thing that this does, it's a quick conformance test. They take about 45 seconds or so to run. And what the goal of this is just to really ensure that this is a valid working cluster. Nothing went wrong during the setup process. There's no weird, like flaky infrastructure that you're going to be dealing with. The primary part of this conformance test is it tries to schedule a pod, make sure the pod runs, and then deletes. So the goal here is really if you want to run a bunch of clusters in CI, you can have a high confidence that you're getting actual working. Your team's not going to be tracking down flaky infrastructure or having to rerun stuff and see if it works on the next cluster you get. It should be very reliable infrastructure. So that's a review of kind of some of the new stuff that we've shipped. But the main thing I wanted to talk about is, we've created this ability to get a dozen or 24 different clusters across all these different distributions and versions in CI. But how do you use this? What's the good way to actually use 18 or 20 clusters in a CI on every PR? The steps that we look at as a best practice right now are to first install your application. So you create the cluster, then install the application, then verify the installation, and then verify the application itself. We're going to dig into details on each of these and show how we're actually doing that. And I have links to a demo app that we actually have too. So install the application. Excuse me, to start with, you don't have to adopt our methodology to install any application here. When you create a cluster in Compatibility Matrix, we give you the kube config. And then you can use the replicated cluster kube config CLI command to download that, and it's cluster admin level access. So if you want to use Helm or kubectl or Kustomize or any kind of custom like workflow that you already have, you can run that. You have a full kube config. I'm going to show an opinionated way on how we actually can make it really easy to install an application, but it's not the only way. Really, it supports any way that you might want to install an application. The opinionated way, we've released some GitHub actions, and they're in addition to the CLI. The GitHub actions, I listed a bunch of them at the bottom here. The ones on the right are just generic replicated GitHub actions that we have around creating a release, promoting a release. The ones on the left are specific to Compatibility Matrix. It allows you to create a cluster, delete the cluster, upgrade that cluster, do an installation, install, and Helm install and prepare cluster. Those three, Helm install, COTS install, and prepare cluster, are the ones I'm going to really talk more about right now on how you can actually use them to easily get your application installed. Helm install just installs any Helm chart. It is a very generic action. It's not really tied to the replicated release. You can have any Helm chart that you want to. You can point to the Bitnami Postgres chart. You can point to a replicated Helm chart that you actually have the SDK embedded into and pushed into your vendor portal team. It doesn't matter. Any Helm chart that you want, this action can install to the Kubernetes clusters created by Compatibility Matrix. You can specify a values YAML. And one of the things that we recommend is this is a good place to put a matrix into your CI. So you can have a values YAML that has different common configurations across the different distributions and actually test to make sure the different options in your values YAML work across all the different distributions. And it supports the original Helm repos to do an installation from, or it also supports an OCI-based Helm repo. We use this quite a bit, and there's some docs and links on this action. If you are shipping a COTS application, we also have a very similar thing for a COTS install. So instead of Helm install, it'll do a COTS install. And you provide a license file, and this will handle installing the version of COTS CLI that you actually need. You specify the version in the action, that's all you need to do, and the license, and then it will install that COTS application. You can also specify the config values. So it's not just install the application and get it running to a config screen. It'll actually configure the full application so that you can run tests against that application afterwards. This is just really a wrapper around a couple of different things to make it really easy to do that installation. And the last one is even more opinionated. This is a prepare cluster action. Prepare cluster works for both Helm and COTS in applications. With a Helm install or a COTS install, you're still building a pretty composable modular workflow where you actually create the cluster, you specify the version in the distribution, and then you do your Helm install of the application and then test the application. With the prepare cluster action, you just specify the version of Kubernetes and the distribution you want, the path to your Helm chart, or the path to your COTS application. You don't have to specify a customer, a license. You don't have to go create the cluster. It's one very simple action, and you can put this in a matrix, and it will actually create the cluster, create a customer, create a test license, that test the application for you, and then that license will automatically be deleted in a short time after that cluster is terminated too. So this is just one way that you can not have to kind of build that modular workflow. If you have a very, traditional, like I just need to install this application and test it on a dozen different clusters, this is a really good path to do that. So now we've installed the application on this array of clusters. Then what we want to do is we want to verify the application. The way that you can verify an installation is through application conformance tests. And an application conformance test isn't really testing end-to-end of your application. It just verifies that the application installed the way that you actually think it should have installed. You ran a Helm install, you ran a COTS install, or your operator did whatever it's supposed to do. You have a cluster that your application should be running in. A conformance test is really just a way for you to write declarative assertions about what should be in that cluster now. So a couple examples I put at the bottom here. You might have your application as a matrix that in a Helm chart where somebody can enable Postgres optionally. And you want to verify that at the end of that installation, if Postgres enabled is true, there's a stateful set for Postgres. And if it's false, there's not one. Helm tests can do that offline, but like a real verification that it works inside the clusters would be using Compatibility Matrix. And an even more runtime example would be if your application has an operator and you do a kubectl apply of a custom resource, you can write an application conformance test, a declarative manifest that says, now I expect these resources to actually be created and running in the cluster. An example of that here is using a project from the CNCF ecosystem called Chainsaw. And I have a link here on the screen that we'll share the slides and you can click on, and it shows a simple way to install it. But it allows us to, in our matrix, say, I expect these resources to be created, and they're minified versions of the Kubernetes manifest. So all of the stuff that we want to make an assertion that actually does exist in that cluster are the things that you specify. So this is a way just to verify that the application installed the way that we expected it to install. Now we've installed the application, we've confirmed that the application installed properly. Chances are we have a set of end-to-end tests or integration tests or some other type of test that we want to run against the application. And so how do we actually access the cluster? There are a couple different ways. These aren't really kind of specific to Compatibility Matrix. They're just the traditional ways that you would access an application in Kubernetes. You could run kubectl port forward. You can install an ingress controller. And I called out the ngrok ingress controller here. I'll explain why. Or on cloud providers, many of the cloud providers, actually all of the ones that we support, Azure, Google, and AWS, all support deploying services of kind load balancer. And those will work in Compatibility Matrix, and you'll get an ALB or whatever the underlying cloud provider provides for you. That'll just work as is. On the VM-based clusters, like curl or K3S kind, those are running on VMs, so there's no cloud provider that will provision load balancers for them. So the recommendation now is to either use kubectl port forward or the ngrok ingress controller. Today, no other ingress controllers are really supported. You can install like the Nginx ingress controller, but it's not going to allocate an IP address. So it's not going to, you can do path-based routing, but it's not going to allow you to get ingress into that cluster. And you also have to bring your own ngrok tokens today for this. I'm going to dig into this a little bit more. So ngrok is basically a tunnel from that cluster out to the internet on a custom domain name that gets created when you create that ngrok ingress. like an example workflow here in CI of how you would use ngrok to test is on the screen. And I highlighted in yellow the specific parts that you want to insert into a common workflow. The parts in white are probably pretty common. You want to create a cluster, install the application, get the kube config, things like that. After you verify the installation, you install an ingress controller, and then you apply an ingress object. And the ingress object just dynamically creates a DNS record in a tunnel for you to access that cluster. It's running on a VM inside the compatibility matrix. After you finish running your tests, you delete it and then delete the ngrok edge and domain so that you're not, leaving records sitting around in ngrok. We have an example of that in the Slacker news application, and we'll include a link to it here. It's on that same PR that was on a couple of slides ago. Now we want to actually verify the application. So we verify the application using any of the traditional means of verifying an application, from end-to-end tests. This would just be where you test your application functionality. You can run Playwright, Cypress, really anything you want to. You bring your own tooling. You run your own existing end-to-end test suite that you actually have. You also can do performance testing. Again, bring your own tooling. The cluster's available. You have ingress. You have access to the application. K6 is common, but you can bring whatever you want to test it. It's not really load testing. It's really performance testing of the application, though. And then you also, could easily run chaos testing. So bring your own scenarios from Litmus to SteadyBit to any of the other chaos testing tools to verify that your application works in end customer environments, which may have things like pods restarting and nodes getting replaced. Then we went through like a scenario of installing, verifying the installation, verifying the application, but sometimes we don't test it because it's always going to be green. We test it because it turns red sometimes, and we need to be able to debug why the tests failed, what happened in the application. One of the things that we actually recommend is longer TTLs on the clusters, but delete them when the tests are green. I'll explain this a little bit more. We have a TTL, and the default is 1 hour. You can set that as short as you want to. You can set it to 10 minutes because your tests will complete in 10 minutes. A pattern that works really well, and I'm going to show an example of this, is to leave set that TTL to something a little longer than what you need. Set it to 2 hours or 3 hours, and at the end of your CI run, delete that cluster. So the cluster's only actually running for the amount of time it takes for your tests to run, because you're automatically you're explicitly deleting it at the end. But in the event of a failure, that cluster will stay up and running, and then you can get the kube config, and the developer can manually look at that cluster if they need to grab some additional logs or whatever it is that they need to do. If you don't do that, we have recently added the ability to extend that TTL after the cluster is running. So you can have that cluster running for an hour or for 30 minutes, something went wrong, developer wants to be able to test it, they can use the replicated CLI to say, oh, keep this cluster running for another 6 hours. I need to keep playing with it. And they can delete it. So they have ability to modify that TTL of the cluster while it's running. And we do have the troubleshoot project, and a really good pattern, and we use this internally, is to collect a support bundle on failure. So in the event that CI fails for some reason, automatically generate a support bundle and attach it to something. Like the pattern that works really well is to attach it as an artifact to the workflow itself. So it's really tightly coupled into that CI run. A developer who's looking at why did this fail, there'll be an artifact attached to the bottom of that CI run. The link at the bottom, it's kind of a long link, actually shows how we're using this in COTS to generate a support bundle on failure of CI. And we're just using the failure GitHub function at the bottom and generating a support bundle if CI fails. And so it won't generate one every time. So I'm going to go through a recent example of us using Compatibility Matrix to debug a failed CI run. We have a test application. It's called Slacker News. We test every pull request in GitHub against all of the different distributions on Compatibility Matrix, and it's generally green. Where everything is working fine. And this, you can see this PR in the Slacker News repo. This is an actual thing that happened recently. After one commit into the project, OpenShift failed. And you can see the screen on the left here, the image shows how that CI run looked, where all the other distributions passed, but OpenShift was failing. And we needed to figure out why. So we tried to reproduce it locally. We don't have an OpenShift cluster locally. So we were using our dev environments, K3s and kind, and everything was continuing to pass just fine on those. But it was failing on CI runs in OpenShift using Compatibility Matrix. So luckily, we followed the advice that we had before, and the cluster had a longer TTL and it wasn't automatically deleted at the end of CI. So we were able to access the cluster and do a little bit of debugging. I'm going to show you how we did that. We use the CLI to list the clusters. So replicated cluster LS, you can see we're naming the clusters with the commit SHA at the end, the distribution, and then the commit SHA. So we're able to find the cluster in this list, and it was the 413 OpenShift cluster. And it's still running, even though CI is still running on some of the other ones in the screenshot, but like that one's running. I grabbed the kubeconfig from it. So I just ran replicated cluster kubeconfig, and it merged the OpenShift kubeconfig into my local kubeconfig, and then list the pods. It's not the most complex application, so there's not a lot of pods in the cluster, but we list them. Okay, the pod is running. That's probably step one of debugging. It's a good sign. That's not the problem. So let's grab the logs from the pod. So when we grab the logs from the pod, we realize that this is a Node.js application that's using SQLite. And in OpenShift, it was failing to open a database file. OpenShift, runs with a different security context and a pretty restrictive file system. So we're able to like debug this. And this was just the information that the developers needed to be able to go back and make the pull request to fix it. Like we can't write to the directory that we thought we wanted to write to. But Compatibility Matrix caught this early by testing on Slacker News. That's the end of that demo. And if you're interested in getting started, Compatibility Matrix is available in the vendor portal today. If you just log in, there's a request more credits button. If you click it, we'll add some test credits to your account. We're happy to help get you started and walk you through it, but it's a pretty, hopefully pretty straightforward process to get started with. And that's it. Take any questions?
Lots of good conversation in the chat. Feel like maybe most of the questions have been answered. Are there any questions we want to vocalize here? Maybe if anybody, Chris or Josh, have any thoughts on things we need to talk about instead of using the chat?
I saw one question that was asking about if a test fails, if you can use kubectl to access Compatibility Matrix, and the answer is yes. You can get a kube config and interact with Compatibility Matrix however you like. And also, I hope I'm saying this right, but it sounds like we're going to have a blog coming out about using support bundles with Compatibility Matrix as well, which is another way after a run to kind of capture the environment and see what it looked like.
Yeah, the support bundles workflow is really useful because it's attached right into CI then. And if it's like, if a pull request comes in overnight and you're coming in the morning, you don't have to worry about the existence of that cluster anymore. Like that artifact sits there, so you can just debug it asynchronously.
Cool.
It looks like SJ is also pointing out we did fix sbctl with support bundle to work with K9s. And so SJ is saying that following that same pattern Mark's talking about allows you to download the support bundle and use something like K9s to inspect it very easily. So cool. I hadn't heard if any customers were using that, but one of our engineers likes K9s and said I can fix that. So they'll be happy to hear that you're enjoying it.